Section 5.1 deals with differentiation of natural logarithmic functions. Some calculus books do this early when you're taking derivatives of everything else. If that's the case, the front of the book will say early transcendental functions. If not, then they'll do it separately at the end. Most colleges do it separately at the end, but it'll just kind of depend on where you go. So we're going to look at natural logs, and just before we get into differentiating them, you need to know these properties because it will help you try to avoid things like the product rule and quotient rule if you use these properties to simplify. Remember that natural log is base e, and that's just understood to be the base. And anytime you have a natural log of 1, it equals 0, because e to the 0 power is what would equal 1. So if you think of that, kind of looping of the log and the definition of logarithms, when you put them back in exponential form, that should make sense. Another thing, remember that if you have the log of 2 things multiplied, you can split that into 2 separate logs added. And I always kept that straight because I know that if we multiply with like bases, what do we do to our exponents? You add them, yeah. And so since logs act like the inverse of exponents, then 1 log multiplied can turn into 2 logs added. If we have the natural log of something to a power, remember that we can take that power and bring it down in front and make it the coefficient. So we have the log of a to the n is really equal to n times the log of a. Then if you have the log of 2 things divided, you can change that into subtraction. Just remember that whatever is on the bottom will become a minus or a negative natural log. And the reason for that is if you're in the denominator, that's understood to have a negative exponent. And so that's why when you separate them like that, anything in the denominator will become minus. And then finally, the natural log of e is equal to 1 because e to what power equals e? And e to the first, yeah. So if you recognize these 5 things, it should be pretty easy for you to get through differentiation. Any questions about that? Okay, well before we get into the actual calculus, let's go back just a little bit and let's talk about expansion of logs. You're going to use this the most because what it's going to do, if you imagine taking this first example up here, if we were trying to take the derivative of it, well, that has a product and a quotient in it. So you would be dealing with a product rule and a quotient rule and the chain rule all kind of shoved into one. It would take a long time. But what we're going to learn with logs is we can separate them into separate ones by expanding them out using the properties. And that will let us take the derivative of each piece separately rather than having to worry about product rule, quotient rule, and all that good stuff. So we want to expand this first guy. How many different logs could I expand that out into? 2 on top and 1 on bottom, right? So I could actually expand it into 3 logs. So we're going to start there. I'm going to rewrite it. Is equal to the natural log of x to the 3rd plus the natural log of the square root of x plus 2. And then the denominator will be minus. So minus the natural log of the 4th root of x minus 3. Any questions so far about how to just expand it out? Every time you see multiplication or division, you just make it into a separate logarithm. And anything in the denominator will have a minus in front of it.
All juniors should be on the way back to class right now. All juniors should be on.
Okay, so that expanded it out into 3 separate logs. And now we're going to use the power property to bring the exponents down and make them coefficients. So this will be 3 natural log of x. And then anytime you have a radical, you need to remember to think of that as to a fractional power. So this would be x plus 2 to the 1/2 power. So we can bring the 1/2 to the front and just leave the natural log of x plus 2. And here, as long as we keep the minus out front, we could make this to the 1/4 power and bring the 1/4 to the front. Just remember to put parentheses on if there's a binomial after the log once you take the radical off. Any questions about that? That is considered fully expanded. If you stop here on this step, it isn't. So you do have to apply the power property even to those radicals in order for it to be fully expanded. So I'll give you a chance to try the second one. Okay, so how many different logs could you split it into? 2. So you have the natural log of x squared plus the natural log of 3x plus 5 to the fourth power. And then we can go one step further and use the power property to bring the powers out in front to make coefficients. So 2 natural log of x plus 4 natural log of 3x plus 5. And that's expanded form. Is everybody okay with that? Yes? Wow, we're
Yes,
super
ma'am.
happy today.
Very okay with that.
Okay. Well, in that case, that brings us up to the derivative of a natural logarithmic function. This is just a formula you have to memorize. The derivative of any natural log with respect to x, you can see here we have the derivative with respect to x of natural log, and they didn't say of just x, they said any function of x, they called it u, okay, is always equal to the derivative of what's after the log, so the derivative of the u, whatever's there, divided by what's after the log, provided that what's after the logarithm is greater than 0, because remember natural logs are only defined for things that are positive. Okay, so one more time. The derivative with respect to x of any natural logarithmic function is equal to the derivative of what's after the log divided by what's after the log. That's why they just say u prime over u, because it makes sense. If we said x, what's the derivative of x? 1. Well, we can't assume it's always going to be 1 over x. So that's why they just call it u, and u could stand for anything. It could stand for, the square root of 3x minus 7. So it's just the derivative of what's after the log divided by what's after the log. It's really an easy formula. Let's try this one. Y equals the natural log of x. It's very simple. It's just x. So what do you think y prime equals? Well, what's the derivative of this over that? So when you take the derivative of a natural log, usually there is no natural log left in it. It's a rare case where it is. And that's all we were being asked to do. Pretty neat, right? Yeah? Excellent. Some of you are still writing, we'll pause. So for our next example, we have f of x equals the natural log of 3x. And there's actually two ways we could do this. So most people, their first instinct is to say, what's the derivative of 3x? 3. And then stack it over 3x. So it's the derivative of what's after the log divided by what's after the log. And then it cleans up to just 1 over x. Okay, so there's the answer. So that's one way to work it. The other way to work it is to expand it before you start. And that would expand into the natural log of 3 plus the natural log of x. Well, when you expand it and you think about it, the natural log of 3 doesn't have a variable. It's just a constant. So what's the derivative of any constant? 0. And you can think of it this way. The derivative of 3 is 0 and 0 over 3 is 0. So that would just give us 0 plus the natural log of x. Its derivative is 1 over x, because the derivative of x is 1 and 1 over x. So you can see we'd get the same thing either way. Sometimes it's easier not to split it up, and sometimes it's a really big headache if you don't split it up. So if you start to get into one that's really bogged down, stop and back up and say, okay, could I expand it out and make this easier for myself? Let's try this one. Y equals the natural log of x cubed plus 2x plus 1. Let me caution you, that is not the same thing as the natural log of x cubed plus the natural log of 2x plus the natural log of 1. You can't distribute that natural log across addition and subtraction. Okay, you can only split up a natural log if the things are multiplied or divided. So a lot of people make that mistake. Just be really careful with that. You cannot expand that one. That's only allowed if you have multiplication or division. All right, let's talk about the derivative. The derivative of any natural log is the derivative of what's after the log, so that would be 3x squared plus 2. Just apply the power rule. So 3x squared plus 2 divided by what's after the log. And that's it.
If you could FOIL the bottom, like if that was x squared and it all worked out to where you get x plus something, do you do that, or do you just leave it like that?
Oh, if you could factor it?
Yeah.
It kind of depends on the directions.
That's
If
like
yeah,
yeah.
if the directions said leave in factored form, then you would want to. But mostly, at this point in calculus, we don't care anymore. We kind of have hit that point. So just read the directions. The only time you would have to factor is if you were trying to find like critical numbers. You know, because then you would want to set top and bottom equal 0.
Are we gonna do that?
We are going to do that.
I hated that one.
Well, it's good to review it then before you go off into the big world. Let's break it right there because we're already at 11 minutes. Everybody say hi to Jonathan.
Hello.
Hi, Jonathan.